Some applications. In this chapter, we will undertake a theoretical study and will hardly mention specific applications. More information about various applications can be found in the references mentioned in section 11.8. Here we will shortly mention a few. Spectrum auctions, held worldwide and in particular in the United States, have received the most attention. In such auctions, a large number of licenses are sold, each license being for the use of a certain band of the electromagnetic spectrum in a certain geographical area. These licenses are needed, for example, by cell phone companies. To give a concrete example, let us look at the next scheduled auction of the FCC at the time of writing, number 66, scheduled for August 2006. This auction is intended for advanced wireless services and includes 1,122 licenses, each covering a 10 or 20 MHz spectrum band, somewhere in the 1.7 GHz or 2.1 GHz frequency range over a geographical area that contains a population of between 0.5 million to 50 million. The total of the minimum bids for all licenses is over $1 billion. Generally speaking, in such auctions, bidders desire licenses covering the geographical area that they wish to operate in with a sufficient bandwidth. Most of the spectrum auctions held so far escaped the full complexity of the combinatorial nature of the auction by essentially holding a separate auction for each item, but usually in a clever simultaneous way. In such a format, bidders could not fully express their preferences, thus leading presumably to suboptimal allocation of the licenses. In the cases of FCC auctions, it has thus been decided to move to a format that will allow combinatorial bidding, but the details are still under debate. Another common application area is in transportation. In this setting, the auction is often reversed, a procurement auction, where the auctioneer needs to buy the set of items from many bidding suppliers. A common scenario is a company that needs to buy transportation services for a large number of routes from various transportation providers, e.g. trucking or shipping companies. For each supplier, the cost of providing a bundle of routes depends on the structure of the bundle as the cost of moving the transportation vehicles between the routes in the bundle needs to be taken into account. Several commercial companies are operating complex combinatorial auctions for transportation services and commonly report savings of many millions of dollars. The next application we wish to mention is conceptual, an example demonstrating that various types of problems may be viewed as special cases of combinatorial auctions. Consider a communication network that needs to supply multiple connection requests, each requesting a path between two specific nodes in the network and offering a price for such a path. In the simplest case, each network edge must be fully allocated to one of the requests, so the paths allocated to the requests must be edge disjoint. Which request should we fulfill, and which paths should we allocate for it? We can view this as a combinatorial auction. The items sold are the edges of the network. The players are the different requests. And the valuation of the request gives the offered prices for any bundle of edges that contains a path between the required nodes and 0 for all other bundles. Structure of this chapter. We start our treatment of combinatorial options in section 11.2 by leaving aside the issue of representation and concentrating on bidders with simple, single-minded valuations. For these bidders, we address the twin questions of the computational complexity of allocation and the strategic incentive compatibility. The rest of the chapter then addresses general valuations. Section 11.3 lays out mathematical foundations and introduces the notion of a Walrasian equilibrium and its relation to the linear programming relaxation of the problem. Section 11.4 describes a first approach for computationally handling general valuations, representing them in various bidding languages. Section 11.5 describes a second approach, that of using iterative auctions, which repeatedly query bidders about their valuations. In section 11.6, we show the limitations of the second approach, pointing out an underlying communication bottleneck. Section 11.7 studies a natural, widely used family of iterative auctions, those with ascending prices. Bibliographic notes appear in section 11.8, followed by a collection of exercises.